All right. So that's a how are they doing question in relation to what are the populations doing? How can we tell a client we think the population is fine, we have a lot of individuals, you're doing a great job, keep it up, or change this. This is a how question dealing with what do we think they're using. We've seen them in this area. Which of the habitats we've seen them in are the priority to conserve them? And we had BLM, U.S. Forest Service office out of Dolores ask us that question about this lizard. It's the long-nosed leopard lizard. It's about so long, twice as heavy as my mice. These guys are the lions of this undersurface shrub bear area. They'll eat lizards, small mammals, a lot of grasshoppers, but they're ferocious predators and about so big. This is a female. She has orangish spots on the side of her. She has a little telemeter right back there. They're found in the 4 major desert systems, but only here in Colorado, around Grand Junction and down the southeast corner. Fun predator. These guys are awesome. If you ever get your finger caught in the mouth of one, you'll have a fun time getting it out. I speak from experience. So when they asked us this question, we said, we don't know. Most of the reports for where they see them are these areas that have a lot of shrub, very little ground cover. We think you should prioritize those. And they said, well, we have cheatgrass moving into our areas. What does that mean for them? So we have no idea. So we put telemeters on males and females. This is a male right here with a sagebrush lizard in its mouth. On the other side is the tail. So it broke off the tail and has the tail closer in and must have chased the adult with the tail in its mouth still because they're stacked on each other. And we followed them around. And this is Chris here. He found one underground. During the nighttime, they go burrow underground. And we're looking at 2 types of habitat use for them. What do they select for their home range, and what do they select within their home range? And this is a heck of a lot more challenging than we first gave it credit for. We had 6 individuals in this area. They're not real common. And this is each of their home range is a different hashed color here. We grouped all their points and said, all right, well, this hashed area right here includes all the points we saw lizards. Let's consider this the possibility for where they have been able to spend time. These smaller circles here is a more constrained way of looking at their habitat. It's called kernel home range estimation. It prioritizes those areas that have a large number of the points used by them. Because there could be sections where you have multiple dots and you have an individual that you've seen moving between here, but they have no interest in spending time there. They just have to move through it to get to another area. So we wanted to compare these peak areas where we know they spend time to these other areas where they didn't spend a lot of time, and these other areas just outside we know they didn't even want to go to. So these are core areas, non-core areas, and areas outside of the home range. And so the things that we were measuring while we were doing telemetry for each time we saw one of these lizards is we'd measure the percentage cover of cactus, cryptogrammat soils, forbs, grass, litter, loose soil, rock, number of burrows in the area, anything we thought that would depict why they're choosing an area. And the 2 things that always popped out when people talked about them is there's very little grass, 1% grass on the landscape in these areas, and there's a lot of bare ground. Half the area for these plots that we were measuring was just bare ground. So we're like, all right, this is really matching what we think is happening for these lizards. And this is just where we found their telemetry points. When we compared it to the other areas available to them that they didn't use as much, it became a heck of a lot more meaningful to us. Because this 52% bare ground was the same everywhere. This is Canyons of the Ancients National Monument. So that really wasn't a selection mechanism for them, it's just what happened to be out there. The thing that really started to show for us is this change in grass cover for areas that nearby they didn't use and areas they refused to even go to. Those areas really had different amounts of ground cover of grasses. So this idea that they can't move through densely grass-covered areas may be true. The story we tell from that is since they're ground predators and they're looking for lizards and grasshoppers, they need a broad area to see because they're sit-and-wait predators. And that becomes even more easy to see between these are the areas within the study area, so the whole broad area they didn't spend a lot of time in. These are the areas within a home range. These are the actual telemetry locations where we found them. There's not big change between their home range and where we actually found them for where big sage, the major shrub component, was. But you look in these areas that are dominated by cheatgrass, there were no telemetry locations despite these being prominent proportions of the landscape nearby. And the fun things that we learned from this is that the reason they kind of like shrubs is they actually spend time in them. So this is a long-nosed leopard lizard that's 2 or 3 feet off the ground. Here he is in this shrub, and here's a female that was found on a... I'm not sure why they spend time there. They're not able to bask as well. I think it'd be difficult to drop in on a predator, on a prey item, but they seem to spend some time in them.
I have a question.
Yeah.
What do they prey of? Birds?
What do they get preyed on? Yeah.
So are they fleeing predation?
We didn't see it when we were there, but I would imagine any raven in the area that's flying over could prey on them. Any birds of prey, any coyote moving through the area. Saw some foxes move through the area, so anything that could find them. So that might be why they're there. Middle of the day, yeah, that's a balance you'd have to figure out what your probability of being preyed upon and what's the probability of you finding food. But realize, if they're eating prey items like that lizard, they can eat things up to 3/4 their body size. You eat an item like that, you don't have to eat for a week or so. You're good for a while. So that might be why they spend time in here, is they're hanging out so they don't get seen. All right, so those are 2 really data-intensive projects about how we try and answer what we think is important for, yeah.
Well, before you move on, so the impact of cheatgrass could be significant if it moves in those core areas.
That's the story that we are telling, is that if you want to make sure that this lizard sticks around these habitats, you really have to be conscious about the expanse of cheatgrass. The next management options for dealing with cheatgrass after that become more problematic. Is that when you start researching the methods of trying to control that, it's tougher. But we were really excited to be able to answer that question and get some more information about it. But we think we probably need to study this in areas other than just one spot in Colorado. So I'm not going to take you through all of the projects that we have going right now, because you guys don't have that kind of class time, and staring at data is not going to be what you guys want to do. But there's a couple of the projects that dabble into the other realms that Susan already talked about. So we have, this is always a background information resource that we're trying to gain, is that where question. Where are they found on the landscape? And one of the groups that I deal with is bats. That's still a huge mystery for us. There's some big conservation questions about very rare species. We're still trying to answer questions about some of the more common species for species groups of animals. And we're still going into mines and caves looking for where we think bats might be. From those is that we've been able to do a bit more analysis on what we think they're choosing to select. And we've been able to model, this is the species of bat in Colorado most conservation concern, it's the Townsend's big-eared bat. And we've been able to go into mines and caves and start modeling why they select certain areas and what they seem to like. And they seem to like mines that have multiple openings, probably for airflow to keep it cool during certain times, and where the temperatures stay pretty stable, because we think they're hibernating there. We've also been able to tackle habitat use for some bats by putting telemeters. This is a pallid bat found throughout the southeastern and southwestern part of the state. These guys are an oddity in that they glean. They feed on prey on the ground. And so they will land on their prey. Centipedes, scorpions, sometimes small mammals. They tackle some pretty ferocious prey. And found they were using some pretty tall cracks in the southeastern part of the state in the Purgatory River. We've started a more expansive study to get an idea of what habitats are being used by what species by using acoustics. Because bats are so difficult to trap, is now we can analyze their calls to get species identification. To some degree, there's some species that overlap and are difficult. But it's been our best mechanism for depicting what species are using certain areas. In fact, it's part of a North American protocol for monitoring bat populations. And we've started tackling the same kind of survival and population change dynamics that I've been dealing with Preble's metadrunning mice in little brown bats. Because little brown bats are the species, one of the species that's been most susceptible to white nose syndrome. You guys heard that before? So white nose syndrome and wind energy development are 2 new resources that have been decimating bat populations. And we've been pit tagging bats in Steamboat area at maternity colonies, because we don't have access to huge hibernation colonies where this disease seems to hit. So if we can start monitoring those, we might get an idea of how they're doing. And dealing with the migratory tree bat issue for wind turbine facilities. Wind turbine facilities, if you're not familiar, for some reason bats are being attracted to the turbine blades. in large proportion, these migratory tree bats, these heavily furred bats that travel thousands of miles from North America to Central America, for some reason are being attracted to them and hit by them, to the tune of, I think, over 500,000 a year. Don't know why. But there was some suggestion we should ban every one of these bats and figure out how their population is changing. Putting bans on the bats is a much more difficult proposition than putting on birds because it's soft flesh, and they've been identifying that infections can occur at these sites. The bats can spend time chewing on them. So the first rule of any marking technique is that the mark you put on them isn't causing any more stress or survival constraints than not having it on. So we went through an analysis to demonstrate that that's problematic for a monitoring protocol. And then we started a information gathering resource that's kind of new for us, a citizen science project where we're using climbers to help us find new colonies. We found out that climbers, when they're up there climbing, regularly find bats flying out of cracks. These are areas that bat biologists wouldn't have gotten access to. There's a climb in Colorado called chiroptophobia, fear of bats, that has hundreds of bats flying out. And these are areas that we never knew about. So we started using climbers as a resource for telling us where we think we might have bat populations that we can monitor. Somebody came to me last week and said they found one they think has thousands of bats in it, areas we never would have known about. And this last project has been one that's combined my love of conservation with my love of beer. This butterfly, as I mentioned before, the Hops blue butterfly, endemic to Colorado, doesn't use the female flowers, but lays their eggs on the male flowers of hops. And over conversations with a fellow zoologist, how do you develop funding to conserve something like this? This is a small butterfly that very few people have interest in. So we told this story to Adele Brewing Company, and they brewed Celestrina saison in 2013 in bomber bottles, and for every bottle sold, they donated $1 to the Natural Heritage Program to study the butterfly. So my only time ever to see a fat check, we got one. They gave us $12,000. And then the next question is, how do you keep that money around to actually do long-term research on the butterfly? So we started using that to fund honors undergraduate students to do the research for us. So we pay for their time to develop the research, go out and do the field work, analyze the data, and get it out there, and it's the material they use for their undergraduate thesis. This is the second year of doing it. They've modeled occupancy along the same stretch of creek that I studied Preble's Meadow Jungle Mouse at the Air Force Academy, and found out that hops is pretty prevalent, the plant is pretty prevalent all along the creek, and actually the butterfly is found in most of those areas. The thing that we find out is you don't typically have the butterfly if you don't have hops. This shouldn't shock anybody. It's the host plant. But that is useful information for understanding how broad the populations can expand or not if you don't have the adequate habitat. So I think we're just in time to at least provide some time for information. So I knew that Susan was going to tell you the breadth of what we do at the program. I, again, very narcissistically said, well, these are the projects I work on that answer some of the questions that not everybody at the program gets to tackle, but it's only because of client prerogative and some salesmanship on my part.